17 letter combinations of a phone number from LeetCode. The question says, giving a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. So what this question is telling us, it says we have we have a string containing digits from 2 to 9. What does it mean? So as you can see here, a mapping of these digits to letters is given here. So we have we have numbers from 2 to 9, and each number has is representing a few letters. So 2 is representing A, B, C, 3 is representing D, E, F, and so on, right? So what we are going to do, we are going to receive digits as input, like 23, and we should return the all possible combinations of the letters represented by 2 and 3 can give to us, right? So as you see, 2 has A, B, C, and 3 has T, F, so all the combinations. But one thing that need to be considered is if the given digit is 2 letters, the length of the combination is going to be 2 as well. So if for example in here, if the letter is if the number is 1 letter, the combination given are going to be length 1 as well. So what does it mean? So we are saying, okay, B is ABC, right? And if we didn't have this constraint that the length of the combination should be equal to the length of digits, we could return ABC, we could return AB, we could return AC, and so on, right? But we cannot return these combinations because we have a constraint here, and if the number, the digit is given, the input is just one number, we are going to return the combination of 1. If it is 2 number, we are going to return combination of 2 here. So this is one thing that we need to keep in mind, and it's very important. And let's jump to the code and see how we can solve this problem. When we are talking about permutation and combinations, the best way to approach these kind of problems is backtracking. So how can we use backtracking to solve this problem? First thing first, we need to remember, as we are using these digits, but we need these digits are representing letters, we can use a hash map to map these numbers to their representing letters, right? So why we are using hash map? Because lookup in hash map is constant, and that's the best way to do that. And the other thing is the space complexity is going to be constant because we have inclusive number from 2 to 9, and that's about it. So it's going to be constant, the space complexity and time complexity for lookup. And for backtracking, we are going to use a helper function here, and what we are going to do is we are going to store all the combination in result, and we're going to return this result as the output, and we are going to call the backtracking function starting from index 0. What do I mean by index 0? So as this one is represented as a string, it's the type of this digit is a string, so it has indexes, right? So this is index 0 and this is index 1. We start from index 0, and the backtracking thing is gonna iterate over the different all the digits in this example. So what we are going to do, we are going to check the first thing is, like, we are going to check to see if the combination is the length of the combination is equal to length of the digits given to us. So if it is, we are going to add it to the result and return. And if it is not, we are going through this for loop here. We get the letters that are represented by that number, so we get it from this hash map. So we are going to say, for example, when starting from 0, the index 0 is number 2, and we check it in the hash map, the number 2 is is the key and the value is ABC. So these are the letters for the first index, right? And we start iterating over these letters, right? And we call the backtracking, but by adding the index, right? So we call the backtrack with index 1 and letter A, and we it goes all the way back here. Now we are going to check the combination letter is just length 1 and it's not equal to 2 that we have here. So what we are going to do, we are going to get the letters from hash map for index 1, and in index 1 what we have is number 3. So this is what we're going to get here, DEF, as you see. And we are going to call the backtracking function again, but by adding the index to 2, and now the combination is AD. So the combination is AD. We go all the way back again here, and the length of the digits, which is 2, is equal with the length of combination, which is AD. So now we are going to add this AD to result. So AD is added to the result, right? AD is added to the result, and now we return. And when we return, we are going to go for the second letter, which is E. So the index is going to be 2 and the combination is going to be AE. So the length of AE is 2 and the length of the digit is 2 as well. So we are going through this if, and we are going to add AE to the result as well. And the same thing is going to happen for the last one. It's going to be AF, and we're going to add it, and we backtrack all the way to it. After this round is done, it's going to backtrack to here, right? So now we are done with A, we are going through B. So the same thing is going to happen here. It's going to be BD, it's going to be BE and BF, and they are all added to result. And then it's going to backtrack all the way here, and the same thing is going to happen for CD, CE, and CF. So it's pretty simple, and the thing is, as we have only the question had the constraint of only 4 digits, it's gonna be the longest one is going to be 4 digits, and but for the time complexity we would say we have n because of the number of n is the length of the digits. Then this is the length of the digits that we have here, and we are going to have 4 power n combinations, and these 4 comes from the letter like 9 or 7 that they have 4 letters, they represent 4 letters. So the 4 comes from this, and n comes from the length of the digits that they are given to us. And for the space complexity is going to be on, and the reason is for the recursive function that we have here, and the hash map is constant space complexity. So for this one is space complexity constant, and for the backtracking that we are using a stack is going to be on.